Greetings, M squared here. Today we are going to use the quadratic formula to not solve quadratic equations. That's our next lesson. Today we're going to use it to find out how many roots a quadratic equation has and what kind of roots there are. And we do that by using the discriminant, which is the part that's underneath the square root. You better have memorized this already. We've been singing the song. Hopefully you've been singing it over and over again. So let's just talk about what roots mean, right? That means x-intercepts. So there's different things that can happen. I'm going to draw 3 little grids here. Either we have a quadratic equation that never touches the x-axis, or we have a quadratic equation that touches it once and bounces back up, or we have a quadratic equation that actually has 2 x-intercepts or 2 roots or 2 solutions. Those are the 3 things that can happen. So we need to make sure we understand what those are, because we're either going to have 0, 1, or 2 solutions. So remember, today's goal is how many roots do you have and what kind of roots do you have? So this is the how many. It's either going to be 0, 1, or 2. Then the what kind of roots, you'll either have rational, irrational, or there aren't any. Rational, irrational, or there aren't any, or 0, which is rational. So yeah, it's either rational or irrational for our purposes, or none, which later you learn is going to be complex or imaginary, but we're not going to talk about that. We're just going to say there's none. So here's to kind of do a step before that. Let's just talk about the difference between rational and irrational. So irrational numbers, right? They're the numbers. Pi is the most popular one, but they're going to have a bunch of square roots that aren't perfect squares, like square root of 11, square root of 6. But if you get the square root of 49, that's 7. That moves over to the rational camp, okay? So we got irrational versus rational. Rational means it can be written as a ratio, 1/4, 7, those kinds of things. So if I have x alone and it says the square root of 18, is that a perfect square? No, that's going to be irrational. I'm going to have irrational roots. 25, is that a perfect square? Absolutely. So we know it's going to be 5, right? Square root of 25 is 5. So we know that's rational. How about the square root of 0? That's rational. Square root of -4? Can't do that yet. Don't know how to do that yet. So we're going to say no solution or no real roots. Not real. Real, remember, real numbers are the only numbers you know. Rational and irrational are the 2 groups of real numbers. So I'm not going to make you say it's a real rational root or it's a real irrational root. All the numbers you know are real. So we're just going to leave that the real part out. It's just going to be today, either it's rational or irrational. Okay, so there's 4 options. Here we go. Option 1, 2 irrational roots. How do you get 2 irrational roots? It's when the discriminant, I don't know if I went over that very much. This is our discriminant. We call it the discriminant. It's what's inside the square root, right? That b squared minus 4ac. So you're going to have to find that. That's the goal today. Find it, and then that tells us what kind of roots we have. So when b squared minus 4ac, or the discriminant, sometimes I call it big D, when it's greater than 0 and it's not a perfect square, you have 2 irrational roots. So let's do an example of that. Okay, so A is 3, B is 5, C is -4. It was already in standard form, so it was pretty easy. Didn't have to move anything over to the left or right to get it in standard form. So I automatically knew what my A, B, and C were. Okay, B squared, 25, minus 4 times A times C. So this little 4, right, that's just part of the formula. This is my B squared, my A, and my C. Well, what is 4 times 3 times 4? You can just punch that whole thing in your calculator if you want to. Watch what happens here. 25 minus 4 times 3 times 4, -4. Okay, what does it say? 73. Is 73 a perfect square? 73 was our big D, our discriminant. Remember, you're going to have to say what the discriminant is. And then you're going to have to say, well, what kind of roots do I know? Well, it's greater than 0. That means it's positive. It's not a perfect square. So we have 2 irrational roots. Yes, you have to memorize this. 2 irrational roots. Okay? Greater than 0, not a perfect square, 2 irrational roots. Next option, 2 rational roots. So now it's still greater than 0, but it is a perfect square. So let's do an example of that. I've got a 4, 8, and negative 5, so I get b squared minus 4 times negative 5. So that's negative 20 times negative 4. So 2 times 4, that's plus 8. 64 plus 80, that's 144. That's a perfect square. Okay, so my discriminant is 144. How many roots does that tell me I have? When my discriminant is greater than 0, it's positive, and it's a perfect square, and it's a perfect square. Both of those, I have 2 rational roots. Okay, next 2 options. We've got 2 more options. Option 3 is 1 rational root. And what happens? D is equal to 0, or the discriminant, or the b squared minus 4ac is going to be equal to 0. So my a is 1, my b is negative 6, my c is 9. B squared minus 4 times a times c, that's 36 minus 36. D is 0. Well, what does that mean? It tells me I have 1 rational root. Well, that's what that means. My last option is when the discriminant is less than 0. What does that mean? It means negative. That's what I'm looking for. So a is 1, b is 0, because there's no x, c is 18. So b squared minus 4 times a times c, and 4 times 18, I don't know, that's what? 18 times 4, I'm going to find out, is negative 72. Since it's negative, I have no real roots. Later you'll learn about imaginary roots, but I have no real roots. Those are the 4 options. Write it down. Let's get started. So now we're just going to go through a few examples of finding the discriminant and seeing what kind of roots they have. So notice this is not in standard form, so I need to get it in standard form. That means I subtract 16 from both sides. Some people forget to do that, and then they have the wrong A, B, or C because they had it on the wrong side. So once it's in standard form, then you can find your A, B, and C, right? So this is A, this is our B, and this is our C. So it's negative, I'm sorry, not negative. It's B squared, that's negative 9 squared, minus 4 times A, which is 3, times C. So what is that? 12 times 16 is 192. So I have 81 plus 192. And that equals 273. So my discriminant, which is the first part, is 273. Then I've got to look through all my options. It's positive, and it's not a perfect square. So that means I have 2 irrational roots. Okay, let's try the next one. It's not in standard form, so I have to subtract 4 from both sides. I'm sorry, I have to subtract 5 from both sides. So my A is negative 8, my B is negative 3, and my C is negative 6. So B squared minus 4 times A times C. So 4 times 8 times 6 is 192. I have 3 negatives. Those 2 can cancel out because 2 make a positive, but it's still negative. So I have 9 minus 192. Well, what do you notice is going to happen there? You're going to get a negative answer. Well, when it's a negative, what do we know about our discriminant? Well, I'm sorry. What do we know about the number of roots that we have? There are no real roots. Remember, when the discriminant is negative, we've got one of these situations, right, where it's not even crossing the x-axis. Negative going down. Okay, last one for today. A is 5, B is negative 20, C is 20. It's already in standard form. So B squared minus 4 times A times C. 20 times 20 is 400. 400 minus 400 is 0. So our discriminant is 0. That means I have 1 rational root. So when you're solving quadratic equations, sometimes we find the discriminant first because then it tells us about what kind of roots we're going to have. And it does actually help when you're trying to graph, whether it crosses the x-axis or not. It's just a helpful little thing. So that's why we learn it. So next we're going to solve quadratic equation, but good luck with this tonight. M squared, signing out.